Conditional probability. We have a table here that is about hours worked in the last week. Labor force status means whether the worker is a full-time worker, that would be the status of this one. The status of this worker would be he's part-time worker. So here are the status. These numbers you see up here are the hours. So take, for example, 26. Full-time worker. Hours from 0 to 19 hours worked. There were 26 full-time workers that worked from 0 to 19 hours. There were 74 part-time workers that worked from 0 to 19 hours. One more. There were 43 full-time workers that worked from 20 to 29 hours, and there were 82 part-time workers that worked from 20 to 29 hours. If you go to the end, you'll notice that there were 377 full-time workers that worked 50 or more hours, and there were 24 part-time workers that worked 50 or more hours. Here are the total of full-time workers, the total for part-time workers, and this total here is the total of the totals. So this one are how many workers total did they consider. There were 1,582 total workers that were considered in this table. Find the probability that the worker was full-time given that he or she worked 50 or more hours. So right here, the keyword is given that. A probability that is worded, find the probability given that, with this phrase, is called a conditional probability. As soon as you know it's a conditional probability, don't go and get the numbers. First, write the formula for conditional probability. This is the formula for conditional probability. Notice how it's read. The probability of A given, so this vertical bar means given B. And notice how it's set up. The conditional probability has two probabilities, one in the numerator and one in the denominator. Now this part, probability of A given B, what does that mean? It means find the probability of A given you know that you're working with group B. So it's giving you extra information. It's telling you find the probability of A, and by the way, we're working with group B. So write your formula first, and now we're going to be looking for this number, and this number, we divide it, and that would be our answer. So they're asking for the probability of full-time given the person was working 50 or more hours. So before you start plugging numbers in, write your formula. So this is the one that's acting like the A in the formula. This is acting like the B. So this is A, B, and this is B if you look at your formula. So you write this formula down. And now we're going to look for a number that replaces this and a number that replaces this. So where are we going to find the number for the probability of full-time, and this is an intersection. It could be translated into and in English. So full-time and working 50 or more hours. So you go to your original table. Let's look for a full-time. That's full-time and working 50 or more hours. So full-time, you draw a line through the full-time and working 50 or more hours. So you cross the full-time with 50 or more hours. So notice the formula says intersection. Here's the intersection. That's the number we're going to use. So you go back to your formula and we put that number here. That's for full-time, and 50 or more hours intersects. This is an intersection. So you write that number where the intersection takes place. Where are we going to find the number for this? Well, this one just has one piece of information. This one had two pieces of information. This one just has one. So go to the 50 or more and find the total for that and take that number. So here's the 50 or more. Take the total. So it's 401. So you put it here. Now divide these two, and it gives you a probability of 0.9401. So the probability of being full-time, given that the worker is working 50 or more hours, is 0.9401.